All right, boys and girls, welcome back to the drive-through for a challenging 10-4 problem help edition brought to you by the deli. Hungry? Stop by the deli and get yourself some Kroger's coffee cake. Delicious, sweet, savory, on sale today. All right, we're going to start with number 10. This is what they refer to as a walk-around problem. It seems like you're not given enough information. Then you get to the end, and it might even feel like you're not done yet, and then algebra magic happens, and you find your answer. So what they're giving you in this is that AB is 20, BC is 11, so not drawn to scale, DC is 14, and they want you to find, well, I don't want to call that X. They want you to find AD. Okay? So the key to this problem is just starting somewhere and then walk around. They give you a hint that to call this X right there. Okay? That's all right. We're just going to call that X. It'll still work. Okay? So, if that's X, then what I referred to as the ice cream cone theorem tells us that what's this? You follow that? So then what would you call this one? 20 minus X. So then this one is? Okay. Now here's where you got to get your algebra on. So then, if the whole thing is 11, and this part is 20 minus X, how could I find the blue tangent segment? 11 minus what? Now don't let that scare you. It's just, all we're doing is simple geometry with complex terms in it. I've got a segment. The whole thing is 11. If this part was 4, how would I find this part? I would subtract. If this part was 6, how would I find this part? I would subtract. So all I did was subtract. Now let's clean that up. What does 11 minus 20 minus X equal? Well, the X is going to turn into a positive X, right? And 11 minus 20? So we're just going to call that X minus 9. So then what is this tangent segment right here? 11 minus 9. Sorry, X minus 9. So, now use that same logic to tell me what we're going to refer to that green segment is. 14 minus parentheses X minus 9. What's 14 minus a negative 9? 25, and then a minus X. Thank you. 23 minus X, sorry. So what am I going to call that green one? And what are we looking for in our answer? We're looking for AD, right? So what's AD? It's X plus 23 minus X. So what's AD? It is 23. Got it? Got it? Okay, so this is the next one. This is called a common external tangent problem. Let me draw the circles the way I did in the first bell so that you can see that it's okay to make a mistake here. Okay? Two circles of radii 10 and 5 are 13 centimeters apart. Once I got to this point, I realized I have drawn it wrong. You see what I did wrong there? How far apart are those centers of the circle? 13, right? But mine right now are at least how far apart? They're at least 15. So that means those circles must overlap. Do you understand that? It's kind of an important part of this question. I'll tell you this. if you can't draw a really good picture, then you're going to have a really hard time doing these questions. Okay? All right, so there's centers. In order so I don't like muck that up and make it all complicated, I'm going to draw it down here. Those are 13 apart. Okay? Now, in your book, there are written directions to how to do these problems in the example section. I'm giving you the video directions on how to do them. So, your first step is to draw the required segment. So they want a common external tangent. So I could draw one on the top or the bottom. I'm just going to draw one on the bottom. Do you understand that that's a common external tangent? Your next step, so step 2, is draw radii to the point of tangencies. Now hopefully you paid attention in the video and learned that what kind of angles were formed there. Right angles, or 90-degree angles. So I want to label them very carefully. Okay? Now what's going to happen is if you don't label these right, you're going to end up calling this thing here a right angle. Okay? Step 3, I guess we're on, is draw a line from the center of the small circle that is parallel to your tangent line. So what line is that green line parallel to? The blue line. So what kind of angle goes here? And what have I just drawn? A rectangle, and what else? A right triangle. That's the key to this question. Now we have a right triangle. So what's the radius of the smaller circle? 5. So this is 5 right here. So this drawing is clearly not to scale. What's the radius of the larger circle? So if the radius of the larger circle is 10, what is this little piece right here? That's 5. This is 13. So what's the green segment? It's 12 by Janet Jackson. And so then what's the blue segment? And the answer is 12 units. Okay? So you're going to want to get practiced on that. We'll finish up with one more example, and that's a common internal tangent. The centers of two circles with 3 and 5 are 10 units apart. Do these two circles overlap? Well, I think we know that they don't, right? Because how far are their centers? Well, their centers are 10 apart, and 10 is more than 8, so they must not overlap. Does that make sense? All right, so pretty similar strategies for this. So the first thing I do, I draw the required segment. Okay, this time it's an internal tangent. Do you understand the difference between the two? Second step, draw my radii. What kind of angles did I just form there? Right angles. Third step, still the same, okay? Draw a segment from which circle? Remember the steps? The smaller circle. Way to get ahead, Grant. Parallel to what? Parallel to the desired line, which is the blue one. So you might be saying, well, hold on. That didn't do anything for us. What if I extended that red radius? What have I just formed? I've just formed a right triangle and a rectangle. So now let's type in what we know. Okay? What's the smaller radius? So what's this right here? Okay, what's the bigger radius? So what is this leg? And what is this well, isn't this a right angle right here? So is this the leg or the hypotenuse? And so our hypotenuse is what? So we have an 8 and we have a 10. So the green line must be by Michael Jackson. I told you he was everywhere. And since the green line is 6, the blue line is, and that's our answer. Can I get a relatively excited boom with Alex in the house today?